So, welcome everybody. I was waiting for Vikram. I knew he was coming, and he's always late. So, yeah, thank you everyone for coming. So, welcome to the App Builder Zurich. I'm your host, John Riordan. I kind of organized this thing. I started doing it when I was developing software, more or less, and I kind of moved on from writing software. But I actually manage a team now of 30 developers in Bern. So, kind of getting back into the development cycle. An interesting team. It's a mixture of professional developers and learnende. So we have from design, we have about 10 designers, about 15 to 20 developers, depending on time of year and how many courses there are going. So I'm actually building up my knowledge in developing, especially in JavaScript and in React at this stage, trying to cross-platform development. So anyway, this event is actually sponsored by Swisscom. So I actually work for Swisscom right now. So I managed to get them to give us some money for this, so the drinks and food is sponsored. Drinks from the fridge, don't worry. It's too warm. I actually have to pay for the fridge, so enjoy the cold drinks. So I'd like to welcome Philipp Ackermann. He's going to be presenting to us about AR and VR. He's done an app to do it. He actually was telling me, he a bit like me, he gave up writing code for a while, and then he started again. So, Philipp, the floor is yours.
Okay, thank you very much. Okay, so John, thanks for the invitation. I go through the slides here. I'm a lecturer at the Zurich University of Applied Sciences, doing lectures in Winterthur mainly, but also here in Zurich. And as well, I'm an app developer, so I'm a lecturer since 5 years. And before I switched the job, I wanted to prove myself that I still can code. So I started some apps. The app I will talk about is VR. So AR and VR is in the wording, so that's the main topic. I started with an app called Artist Info on the Mac, and then moved on to iOS, and there is even a web version. And the reason is that I also playing a lot of music. I'm a bass player and listening to music, digital, of course. And the reason for the Artist Info app is that I miss the information about the artists playing the songs. So my app is bringing back all the information about who is playing this cool guitar solo and so on. Okay, but today it's VR, but please feel free to check the other app as well. So I want to give a short overview about the terms AR and VR and mixed reality. Then what are the typical use cases of AR, and then give an overview about the features and functions of my app. And then, of course, you are interested about the technology that is used for it. And then I try to generalize the lessons learned, what can go wrong, what has to be improved, and what are the future challenges in augmented reality. I go quickly through this definition of reality and virtuality continuum, defined by Paul Milgram already in 1994. On the left side, we have the real world, the real environment as we are living in, and on the other side, we have the virtual reality, so generated by computers via computer graphics, so purely synthetic. And in between, there is that mixed reality approach, where augmented reality uses the real-world image or video stream, but on top there are some additional information generated by the computer. There's also the world of augmented virtuality, so you bring in real-world data into virtual reality, so maybe video or real sensor data into a game or VR environment. And with my app, I cover augmented reality and virtual reality, so therefore we will move along that continuum a little bit. Then typical use cases. Of course, augmented reality became famous recently in the game world with Pokemon Go. But there are, of course, other applications that make sense. Marketing, education, training, maintenance and repair are the typical applications. So, will e-commerce become a-commerce in the sense of augmented commerce? Maybe some niches will profit, especially if there are design and style options that you want to see in the context of your real application. And maybe there are spatial contexts, geometric constraints that have to be fulfilled, and then it makes definitely sense to place products into the real environment to check if that fits the requirements. Also, if the product is very complex, visual explanations might help to understand your product. So here is an example of how to use augmented reality in an AR application. So you try out your glasses on your real face. So this is a Ray-Ban application. What is now very famous as a typical AR application is the application by IKEA. So you place your furniture in your real environment, and it looks quite good. The rendering is quite perfect, the light shading is correct, and so it makes really fun to place furniture from the catalog in your home and test whether you really like it. And you can add additional parts to it and place them as well. So now the camera will move, and then you will see a problem. So occlusion is not implemented at the moment in these augmented reality developer kits that are available. AR Kit and AR Core from Google. They have some limitations, but it works on some occasions. So the interesting thing is that I think these objects that are placed into these augmented reality sceneries are becoming more and more intelligent and smart. So they will get some physical simulation, configuration logic, functionality that can be tried out virtually, animation of complex tasks, etc. So that it's not only seeing an object, but you can interact and test in a virtual environment. This is a quite interesting example. So you can place your car in front of your house and check the color and the wheel options, and then discuss with your partner whether this option is right. And you even can simulate and drive the car with the steering wheel. Yeah, it's a fun example of an augmented reality application. Okay. Then other aspect of AR and VR is the fact of immersion. So VR is totally immersed. You have your virtual world and the outer world is not existing. But I think there is some spectrum that goes on from desktop VR to the mobile VR and mobile AR application to the glasses, where all the immersion is then, of course, definite in the VR glasses. If you have an AR glass, of course, then it's a mixed reality approach. And if you try to implement content for VR and AR, you have to think about which devices are supported, and they have different interaction controls that are needed. but you have that continuum of the desktop to the mobile to the glasses application that you think you have to provide support of. What's interesting at the moment are two trends. One is web VR, so that the virtual reality applications can run in the browser, which makes it very interesting for deployment purposes. And if it's running in the browser, it runs on any device. And WebVR also allows declarative content definition, like HTML DOM structure. You can add VR 3D content in the same way using JavaScript libraries. And then mobile AR is now coming up using smartphones and tablets without special hardware, so no stereo cameras or depth cameras needed. They provide AR experiences with your quite powerful smartphone, but of course then you can have a wide distribution of your app. So Apple provided ARKit last year, and then Google came along with AR Core. There are some SDKs for developing AR applications. There is no winner yet. And as you know, Apple started the race for their mobile AR, but they already bought companies 2 years ago. Interestingly, some European companies, so Metaio from Munich, and FaceTime from the EPFL from Lausanne. And then, as an outcome, they launched in autumn last year that ARKit. Google as well bought a lot of companies and started the Google Tango project. That was a tablet with stereo camera and depth cameras, with more functionality that is available with a smartphone. But they stopped that project and then launched AR Core in November last year as well. What will be a play as well is Unity. They provide game development toolkits, and typically they provide adapters for several devices. VR glasses and AR devices are supported as well. They lag in time a little bit behind of native apps, but in the future Unity will be a big player here as well. There are a lot of other SDKs. The most important differentiation is it marker-free or does it need markers? So markers means that you have to place a known image to the scenery, so that the registration of the camera can be made on that marker. If it's markerless, then the features have to be detected automatically, and this is what is of interest at the moment. Today, ARKit and AR Core, Google, and as well the Microsoft solution for the HoloLens, they are marker-free. The other ones need markers typically. Okay, so that's a roundup of the state of the art, what is available. Then I want to continue about the app that I started shortly after the ARKit was available last year. And I had the idea about the app coming from a research project that was based on that Google Tango device. But because that development stopped, I wanted to switch to the new technology. So the main idea is to use AR to scan a room. The floor, the walls, the doors, the windows, and then generate 2D floor plans and 3D representations of these environments. And the other goal was, how can I share these models so that they are not bound to the device? I want to send it to my colleague, for example. And this has driven my decisions about the technology, which I go into details afterwards. So the requirements for that app, and of course for the AR kit in general, is that it runs on iOS 11 and it needs some powerful devices, but it goes from iPhone 6s upwards, and also iPads are supported with the newer processors. So what the app is doing, okay, there are missing some parts here. You can capture the floor and the height of the room and doors and windows, and then out of these measured points it will generate automatically 2D floor plans, 3D visualizations, and then you can use the 3D model as well in a VR setup. So that Google Cardboard approach for having a stereo view of the model. Okay, so here is it in live and in color. So you grab the floor and then the walls and the height, have a grid measure, and then you can cut out the doors and walls, define the type of the door, and then afterwards you can then have some metadata, so the area of the floor, and then generate 2D and 3D automatically, viewing it on the device. So you can go from AR to VR in 1 minute, covering 2D and 3D as well. You can capture several rooms, and then if you select them, they will be merged automatically, so that you have one plan for your apartment, for example, and then you can navigate through that 3D model. Okay, so it's free, you can download it. I brought along some VR glasses, so you can try it out afterwards. So let's see what is going on behind the scenery. Well, you can't see it, but there is a first step of detecting the floor plane, which is that feature detection functionality of ARKit. And when it's detected, you then can point to the corners of the wall and then outline the wall structure of your room, the height, and then you cut out doors and windows, define types, so you pop-up menus come up so that you can define the orientation of the door and the kind of windows you have. This looks quite strange, and it's really a problem guiding new users. Of course, that was one of my biggest mistakes. During my programming phase, I tested all the time my new functions and then said, it's obvious how to use it. And then I put it on the store, and of course nobody knew what the heck is going on here, how should I use that thing. And then I came along with the idea, okay, I need some guidance in the app showing how to handle the device with some pop-up menus and sketches about the way to go. So you start here, pointing the device to the floor, and then grab the floor, pointing to the edges, to the height, and then pointing diagonals for the cutouts of doors and windows, etc. At the end, there are a lot of options which can be chosen by pop-up menus, which shows a little bit the complexity of the functions that are available. So you have options for wall material, floor material, door types, and window types. And these types are important because the merging of the different rooms depend on the doors and the door opening directions as well. So what I have from the measuring is a more or less correct north direction of each room. More or less means plus minus 20%. It's not really precise, but it's enough. And then I check that which door can fit with the other one, and then I know that I can merge these elements, removing double walls, and then generate a merged floor plan. So for each door type, there is a counterpart for that merging process, and therefore the door direction has to be correct, otherwise the merging will fail. Okay, so what kind of data is captured? Of course, I have measured points. So for each tab, I have X, Y, Z position. Well, this is not perfect, and therefore I do an alignment of each point. I align to a grid. You can set that up in the settings. For example, the grid for 5 centimeters, and also an alignment for the angulars. So that it's more or less 90 degree mostly if we have buildings, and that will be aligned as well. And then connected doors and walls are sub-elements, doors and windows are sub-elements of walls. And what I do is I try to estimate the subtypes from the geometry. For example, if a cutout goes down to the floor, it might be a door, but it could be a window as well, as it's here, right? But I estimate if the door is on the left, more on the left side of a wall, then maybe it will be a left-handed door, right? Not a right-handed. And so these kind of rules are used to define the subtypes of the elements. And I also use some computer vision to define the material. So if it's brownish, then maybe it's wood on the floor. If it's black and white, it might be a checkerboard kind of floor, etc. Additionally, there are some metadata collected. So the geolocation, longitude, latitude. So I can open the map and see where that room was captured. I have the north direction, the address, and then I calculate floor area, wall area of outer and inner walls, and the curvature of the room. So from these measured and aligned points, then I generate SVG for the 2D floor plan. So from the measures, I generate the SVG document and I present that in a web view. So it's pure HTML, and therefore I can share it by sending it via email from that view. There are some interactions available. For example, I can change the type of the door, which is important for the merging if I did it wrong. So a pop-up menu comes up, and then options are available for turning left-handed to right-handed and reverse and so on. For that, I have to call Swift code, right? So I use HTML, JavaScript calls to call a Swift function that changes my model, right? So that's possible, nice feature. For the 3D visualization, I use WebVR, which is also HTML-like, and I can present that in the web view as well. So I generate these kind of visualizations using 3D.io, a library that turns JSON structure to architectural models. It's quite cool. I will go into details about that. And also here I can have interactions calling JavaScript and Swift code. And the WebVR version with the stereo view is the same code for the 3D model, but with different interaction controls, right? Okay. And then at the end, if I have captured the room, I can upload it to a web editor. And there I can edit it with the mouse. It's better than with touch on a smartphone, and even can add furnitures, for example. So this is a platform provided by Archeologic. Quite cool. So that's more or less the functionality I provide with my app. The AR part of it is implemented with ARKit, of course, and the 3D rendering is using a scene kit. Then A-Frame and is the technology that is used for providing WebVR content. And that 3D IO toolkit from Archeologic is used to generate these architectural models, which then are using can be used on the Archeologic platform in the editor. Okay, let's go into details. The ARKit is using visual inertial odometry to estimate the pose of a moving camera. So if I have my smartphone and I move along, then the technology is trying to find out features on the floor, and then these features are recognized in the sequence of images within the video stream, and from a reprojection of the camera and the recognized features, they can estimate the position of the camera. They additionally use sensor fusion, which means that additional input is used from the accelerator and the gyroscope to find out in which direction the user is moving the device. And that helps to have a quite confident measurement from spaces, including correct dimensioning, which is of course needed if I want to measure rooms. So the basic features of ARKit is markerless camera pose estimation. They take planes. In the first version only horizontal, now in the new version also vertical planes. And then on these planes you can place 3D objects, which are then visualized with SceneKit on top of the video stream. Additionally, they estimate light conditions, so the direction and the color of the light, so that in the SceneKit 3D view you can emulate the same light conditions, so that it fits together quite well. Okay, then for the 3D viewing and the VR viewing, I use A-Frame, which is an open source JavaScript library providing WebVR functionality. So WebVR is the definition of Mozilla, how to use the browser for VR applications. And A-Frame itself is built on top of Three.js and on WebGL. That's the technology stack. And the nice thing, it's cross-platform. So if you have a WebVR application, it runs on HTC Vive and Oculus Rift and Samsung Gear and all these possible devices, and also on that cardboard approach that Google made 2.5 years ago for the cheap version of virtual reality. Okay, and the interesting thing is that with A-Frame you can define VR content with a declarative approach. So you define a DOM structure not only for the 2D content but also for the 3D content. And they support a modular entity component architecture where all these components for geometry, camera, light, animations, etc. Can be included, and then support for different devices and controls are available for a very flexible virtual reality definition. So how does that look like? I don't know whether you can read it, but it's really a DOM structure, normal head, body structure, and then a tag with a scene, which goes from here to here, and then there's a box, a sphere, a cylinder, a plane, which can be seen here, and that is the content that is defined here. And each of these elements has some parameters for position, radius, rotation, color, width, and height, and that's it. So within your HTML code, you define your VR content as a 3D representation. And then the cool thing is, in a A-frame view, you have this icon. If you click it, then it automatically turns to that stereo view, where you can put the glasses on and then have your virtual reality experience within the browser. Who has tried that out already? Okay, cool, yeah. Okay. So, of course, then defining walls and doors and windows is quite a difficult task from these basic geometries, and therefore I use that 3D.io library, a toolkit that provides interior elements, architectural elements, as well as furnitures, and they generate out of a JSON scene definition A-frame content, which then can be viewed in the web view. It's a free open source JavaScript library, and it's provided by Archeologic, which is a company here in Zurich. Yeah, check it out. They have cool stuff provided on that platform. Okay. So that's the basic technology, and now lessons learned, the hard way, of course. Yeah, so the hardest thing about AR is the user interface. We are not used to it, and we have to establish a common understanding how AR should work. And the difficulty is that it's a mixture of a standard UI or GUI, a video stream, and 2D overlays, and then 3D feedback as well. So in this simple screen, you see on the top some guides and warnings as text overlaid over the video, which is a bad idea. Nobody read it, especially if it's on top or on the bottom. It should be more centered and with a larger font, that I learned. Then here you have some icons, so 2D symbols overlaid, so target icon, as well as some text. So while you are dragging, the dimension of the distance is visualized, and also the angular, and it changes color. If it's near 90 degrees, it becomes green, otherwise it becomes red and orange. You see a 3D representation of feedback, this grid, or the height scale, that is a 3D node in the scene graph, and also captured elements like walls or semi-transparent elements within the 3D scene. And this mixture and balancing out how much place you have is in between the standard user interface of these tabs and then the video stream and text sizes and so on is not yet perfect in this app. I have to improve that. Then 3D is also not so easy on these small devices, and navigation in 3D especially. And what I learned is that VR needs definitely different controls than normal 3D. The thing is, if you place your smartphone into these glasses, you can't touch the screen anymore, right? So you have to think about other interaction modes. A well-known one is these gaze menus or fuse buttons. So you have to steer for 2 seconds to that direction, and then they become active. Also, a not so good idea that I had, there are menus here in the normal 3D view that you can change from room to room. And this gaze menu has then the same functionality. And the thing in 2D, it moves from one room to the other, and it might go through walls, which is not so crazy. But in VR, moving through walls is crazy. So the next thing I thought, okay, let's move up and then go to the next room. But I can tell you, that's definitely not a good idea. So my wife tried it out and she screamed because it's really scary. It's woo and zack to the next room. Okay, so it's still available, so you can try it out, changing the settings. But the default is now teleporting. So it closes the view, it gets black, and it opens up, and then you are in the next room. Okay. Then what I use, okay, the nice thing of having that smartphone is they have a gyrometer, so if I turn around, I turn around in the virtual view as well. But moving is of course a problem, because if I move, I run into the obstacles that are in the real place. So how can I move? In 2D I have these buttons here, left, right, and you can see it. It's up and down for moving forward and so on. And then I implemented shake to move. So you touch your glass, ding, and then it starts walking. And then you shake it again, and then it stops. So you can stay here, but in the virtual world you can move. But yeah, if you don't explain that to the user, how does he know? Well, yeah, it needs guidance. Okay. Oh gosh, this is a hard topic. Marketing. Yeah, I did a lot. Of course, you have to provide a lot of information for the App Store. With all the videos and images and text. I opened up a web page. The web page has also a huge section about how to use the app. Nobody reads it. I tried to give press releases. I made a run with Product Hunt, but it doesn't help, right? Because if you make only a one-time shot, you have no chance. And yeah, of course, I'm a developer. I'm interested in the next feature and bug fix, and my time for doing marketing stuff is limited. But the hard thing is, of course, you will not get discovered. No way. That's what is the hard thing. So there are some downloads in these 5 months. Interestingly, it went up. You can see it the last week. Maybe you had made download. Yeah. Okay. Yeah, here you are. So about 86% are smartphones, iPhones, and the rest are iPads. Huh? Yeah.
That's a great advertisement for the app builders.
Yes. Okay. So yeah, that's where am I? Ah, wrong direction. Okay, so here I am. Yeah, so that's the lesson. These are the lessons learned. Of course, I have ideas what I could develop in the near future. Scanning interior objects, furniture and equipment, and then add more logic, so more classification rules with geometric constraints behind it, using more computer vision, and especially it already runs some ML core stuff during the scan operation. I use that mobile net network from Google, and it it detects some objects, but they are not interesting enough for me. So I have to train the network by myself. For example, door types and window types and so on. Or object types, right? But it already runs, it gives me feedback, and object feature recognitions with confidence and so on. So I think there can be quite interesting applications in these areas. And then, of course, more UI improvements. Never-ending story, I think, for augmented reality applications. Yes, so overall, I think we move from multimedia, where we combined text and graphics and audio and all the web stuff we know, to a kind of multi-realities approach, where we combine augmented reality, virtual reality, data visualization into a smart 3D environment, which is, I think, quite interesting. But there are some heavy challenges. Usability, I already mentioned. In the long run, also, how do we generate benefit with AR? I mean, visualizing a product on a table, okay. We have seen that now. Now we have to really provide user benefit, or at least interesting storytelling patterns in AR that are adequate to that medium. The next thing is a little bit harder. The problem of these AR sessions is that if you close the app, the correlation between the camera and the environment is lost. So the calibration of the camera is not the calibration, the registration of the camera with the real world and the features that are used within the session are only valuable in one session. But what we would like to have is an augmented reality that works outdoor and indoor in a permanent way, right? So if I have some interesting features recognized and captured, I want to be sure that if someone else comes in the same room, he gets the same object already I had captured for all, maybe. So we need some kind of searchable and shareable augmented realities, and therefore we need the persistent point cloud with object features that are re-registerable. And if we have this, then we can talk about social mixed realities or social augmented reality, because then we can share what we capture, for example, or what we experience in virtual reality and in augmented reality. This will then generate, of course, some heavy questions. How do we deal with multi-realities? We already do. We have our home reality and our business reality, and I have my music reality and so on. But if it becomes accessible by friends, by all, by Google, then maybe we have to think more about how we share all these things. And of course, we become more and more aware that our current IT infrastructure that we are based on is more or less financed by advertising. All big companies are driven by advertising money. And if you think about AR becoming advertising driven, then it might be not so funny, because then you have a lot of augmented things and the main stuff is product advertising. And I don't think that we want to have such kind of experience in the near future where we are bombarded by augmented reality content driven by advertising money. And the other thing, of course, which also makes me nervous is, of course, if we run around with all our cameras on and stream our experience to the web, then yeah, surveillance of and recognition of persons and so on will become a reality sooner than we would like to. So this is from the film Person of Interest or the series. Yeah. But at the end, I think we can make a happy new augmented reality. We have to work on it. And if you have some cool ideas or try to start a new project, I'm lucky to be in contact with you, talk about exchanging experiences, etc. Feel free to contact me. I can come in the role of the lecturer of the ZHAW, or as my private one-person company, Metason, so we can find out how it will work out the best. I brought my iPhone and my iPad with me with the app installed, and there are some VR glasses. You are free to download the app now if you have an iOS device, and then I'm lucky to help you using it, because maybe you still use some support, and then test the app, give feedback, and if you like it, then please rate or review it on the App Store. So that's my input to the topic of AR, and I'm wondering what you are interested in more details. Thank you.
How much time would you say you spent developing this app?
Yeah, I started mid-October till end of the year, but part-time. I had my job, and then during night and weekend I developed that stuff more or less. So, yes, I spent maybe 250 hours, which is not so bad, and a lot of work went into that productizing stuff of web page and so on. Yeah.
Don't you have students who can do the writing of the code for you?
Yes, that's the step I now start. It's a perfect platform for student works, of course. Yeah.
Absolutely, yeah.
Yeah. Yeah.
Thanks so much. That was very interesting. You mentioned the UI being the most difficult. Is it because of the technical difficulties of getting the labels in place or getting the right orientation, or is it more about what is the right interface for the user, therefore you have to try and fail many times, or is it both?
Well, it's a little bit a challenge on the technical side, because you have to mix 2D and overlays and 3D and video and so on. But the hardest part is, of course, how to meet user expectations. And you can't meet them because they don't have any expectations. And therefore you have to invent somehow the interaction that can fulfill the purpose. And of course it's a step-by-step refinement of the functionality, and you start, hey, great, I can measure points, and then okay, maybe I need a distance, and then you add the grid so that you see the angular level of the points. Also, color coding of all the stuff is strange. I mean, the doors are now yellow and the windows are blue. Blue, of course, because it's out. But yeah, the meaning of colors in that in the AR scene is unclear. Yeah, and the space is so limited on a smartphone. You hardly can add guidance during the context of interaction. I now pop up some guidance. The problem is then you have to click it away, and then you're maybe in another direction as before. So it's yeah, it's not easy. There's a lot of room for improvement. So one of the student works I already did is usability study. And of course it was a mess. Okay. It was not so bad, but yeah. She found out a lot of things that I should fix.
Do you think a voice interface would be a better way of using it?
For VR, yes. The problem is that you cannot use Siri because you do not want to say, "Hey Siri, walk." "Hey Siri, stop." So you just want to say walk, left, stop. So that continuous voice recognition without a round trip to a server is a functionality that I'm looking for. With the Sphinx, it's not Siri. Yeah, so
okay,
I
so
talk to you.
You should give
Yeah.
Vikram give a bit of consulting afterwards. Who else here has written a augmented reality or a virtual reality app? I know Adrian did it the last time, but has anyone here actually written? Maybe you want to give us inputs on what you've actually written?
So I work for Scandit, so we do barcodes recognition, and we already have like an augmented reality framework for like augmenting the information that you can have. So basically, you scan a barcode, and you want like an overlay with like information about the product. So you just query a database and stuff like that. And for that, we don't use ARKit, but we developed some prototypes using ARKit because we want to have like we want to use because if you don't use ARKit, basically you need to scan barcodes all the time, right? But if you use ARKit, you can scan a barcode and then you can move away, go like 5 meters away, and then you just turn, and even if you don't scan the barcode, you can still have an overlay above that product. So that's how we use ARKit at the moment, but it's a prototype for now.
Yeah. Okay.
Cool. I can imagine other shops would be interested in that. I mean, Scan's doing some interesting stuff with 2D at the moment. Actually, I gave my son the Sony PlayStation VR set for his birthday on Sunday, and a lot of the stuff you're talking about, you realize it because you're totally immersed in this thing. It's quite dangerous. He starts walking around the room and falling over stuff. So you probably want to have some kind of your app would actually be very useful as a basis for any VR game, because then you would actually map out the room and then tell the person which part of the thing to actually where you can go and not, like beep beep beep, you're gonna crash if you go any further this way. But I mean, the actual PlayStation 4 set is amazingly sophisticated, and yet it still fails in other ways because of the fact that it's if you turn away from the camera, it can't track you. They have a camera tracking you. They have motion detectors. They have all these things in your hand which you use to actually steer it, and it's still in my opinion quite clunky. Having watched my son using it on the television thing, and I guess that the biggest success example of augmented reality is Snapchat, right? I mean, it's really amazing, and all my kids use it, and they love all those. It's like a continuous kind of update with new features, which is kind of a very good example of how you can make augmented reality interesting, and in fact probably more interesting than virtual reality right now, because it's great. Well, if nobody else has any more questions, then I would suggest, as Philipp said, we have these glasses here, and I guess mapping this room up would be quite difficult, right, because it's so big.
Yeah, let's try.
Yeah, that's why actually, as I said, the drinks are sponsored by Swisscom, so when we're drunk enough, we can go and try and map out the room, and see how we get on. So thank you very much again, Philipp. I think it was very interesting, and we look forward to seeing your app hitting 10,000 in the App Store after this presentation. We're going to put the video out and we're going to promote it a bit. And actually, I organize another community which is social media marketing, and I can highly recommend that for promoting apps. So
okay,
great.
Yeah.
Thanks.